Hello everyone, welcome to our online video tutorial, and today we will learn about class 11 topic sets, and today we are doing its third part. So dear learner, till now we discussed about the subsets, power set, interval as subsets of real number and universal set. In this video we will discuss about Venn diagram, operations on sets and their properties, and symmetric difference and disjoint sets. So let's start today's class. So first we will discuss about Venn diagram. So what is a Venn diagram? Venn diagram is a way to represent the sets. So most of the relationships between sets can be represented by means of the diagrams which are known as Venn diagrams. And it is treated as the one of the most important discovery in the field of mathematics. So Venn diagrams are named after the English logician John Venn, and these diagrams consist of rectangles and closed curves, usually circles. So it's not necessarily that they should be a circle, but usually they are circle. So universal set is represented usually by a rectangle and subsets by the circle. Let's see one Venn diagram example. So here universal set is having the natural numbers from 1 to 10, and set A is the set of even integers 2, 4, 6, 8 and 10, and set B is having two elements 4 and 6. So let's represent them as a Venn diagram. So this is a universal set having all the natural numbers 1 to 10. Let's mark the set A. So this is the set A. So having even integers 2, 4, 6, 8 and 10. And that set B, which is a subset of A. And this concept of Venn diagram will help us to understand many more concepts related with the set theory. So let's proceed towards that. So here we will discuss about the operation on sets, union, intersection, difference and symmetric difference of the sets. First of all, we will discuss about the union of sets. So let A and B any two sets, and union of A and B is the set which consists of all the elements of A and all the elements of B. Then the common elements being taken only once. And this symbol is used to denote the union. And it is to be read as A union B, where it comprises of the elements X. What is X? X either belongs to A or X belongs to B. That means it's a combination of the elements of two sets A and B, where we will list the elements, common elements only once. So here I took an example. Let's set A is 2, 4, 6, 8 and set B is 6, 8, 10, 12. And let's understand with the help of Venn diagram. So here the set A I marked, this is the set B, and if I join them, make a union of them, then what set I will get? All these shaded elements. So let list them. It become A union B is equal to 2, 4, 6, 8, 10, 12. Means these are the elements, they are present either in the set A or in the set B. Here is another example. Here set A is having the elements 1, 2, 3, 4, 5 and 6, and set B is 2, 3. If you notice here set B is a subset of set A. So let's make a diagram. Set A I have drawn and let mark B. So B is having only two elements and let's join them. So what I'll get? I'll get the elements 1, 2, 3, 4, 5 and 6, and which is again equal to A. That means if A is a subset of B, then A union B will be equal to A. Let's take one more example here. Set A is, it is written in the set builder form. First let convert in the roster form. What is set A? Set A is a natural number and it lies from 1 to 6. So 1 is not included, so I will start from 2, 3, 4, 5 and 6. What is set B? Set B is the set of natural numbers from 6 to 10. X lies between 6 to 10. That means 7, 8 and 9. And what output I will get if I do the union of A and B? 2, 3, 4, 5, 6. I wrote the elements of set A, then started the elements of set B. Need not to be written in any particular order. So this is the output A union B. My next example is set A is having the elements 1, 2, 3, 4, B is 3, 4, 5, 6, C 5, 6, 7, 8 and D 7, 8, 9 and 10. Here we have to find out A union B union D. So let's do the first part. So first I am finding A union B. Step by step let's proceed. A union B will be 1, 2, 3, 4 elements of A. Then elements of B 3 and 4 we will not repeat because they are already presented. Then 5 and 6. Now we will make the union of A and B with D. So A union B with D, if I do the union, so first let us list the element of A union B. Now we will include the elements of D also. What are the elements of D? 7, 8, 9 and 10. Similarly, we can do the second part. So here we will discuss few properties on the operation of union. So our first property is that A union B is equal to B union A. Means union is commutative. Either you can do A union B or B union A will give you the same result because elements are listed in no particular order. Second property is associative law. That means you can change the order of union. Here A union B first, and if you see the right hand side, here I am doing B union C first. So associative law is applicable on the operation of union. You have an set A, and if you add nothing into that, that will become again equal to A. That is known as the law of identity element. And phi is the identity of union. So if you add phi to anything, the output will be the same set always. A union A will give you again output A. This is known as the idempotent law. Universal set union A. Just few minutes before we did the students that if A is a subset of B, then what was the output of A union B? B. So in this case, universal set is always a superset of every set. So A is a subset of universal set. So if I do A union universal set, so I will get universal set. So this is known as the law of universality. Now we will discuss about the intersection of the sets. Intersection. Section stands for the part. Okay. So intersection of sets A and B is the set of all elements which are common to both A and B. This symbol is used to denote the intersection. Symbolically, we can say that A intersection B is comprises of the elements X, and what is X? X belongs to A and X belongs to B. This you have to take care. And means in both the sets, A as well as in B. Let's understand with the help of Venn diagram. So I had taken the set A, the same example I had quoted. So set A I mark, set B I mark, and see dear children, this part which is common to A and B both. So this part is known as A intersection B. Because these elements 6 and 8 lies in A as well as in B. So they are common to both. So A intersection B will become 6 and 8. So we have to find the intersection of these two sets. The same example we did with the union of the sets. So set A, set B, and if I do the intersection, I will get these common elements 2 and 3. So here the result is if A is a subset of B, then their common part will be the smaller one, that is set B. Next example is set A is having these elements 3, 5, 7, 9 and 11. Set B is having the elements 7, 9, 11, 13. Set C 11, 13, 15 and set D 15, 17. we have to find A intersection B union D. So first let's solve these brackets. B union D. Let list the element of B: 7, 9, 11 and 13. Now we will write the elements of D. They are 15 and 17. This is B union D. And what we have to find out? We have to find its intersection with A. Now check that which elements are common between this and A. So 3 is there. Is 3 available here? No. 5? No. 7? Yes. So 7. Then 9? Yes. 11? Yes. So likewise, step by step, we can solve them. Here we will discuss about some properties of the operation of intersection. So first, it is similar with the union. So intersection is also commutative as well as associative. Here phi intersection with A will be equal to phi, and universal set intersection with A will be equal to A. So whenever we are taking common, that the set which is a subset of that one, so that will be our answer. So A intersection A, that is idempotent law, and this is known as the distributive law. So here I distributed this intersection over union. So A intersection B, then sign of union, then A intersection C. Now we will discuss about the difference of sets. The difference of sets A and B in this order. In this order means A minus B, and set of elements which belongs to A but not to B. So definition says that difference means set of the elements which belongs to A but not to B. So A minus B means all the elements which belongs to A and X does not belongs to B. So symbolically we will write it as A minus B. So let's take the same example. Set A, set B, and if I make the operation, now this pink part, this is A minus B because these are the elements which are not the part of B. So A minus B will be 2, 4. You can say it as only A. Only A means the elements belongs to A only, not B. And if I am talking about B only, that means B minus A. B minus A will become, yes, you are absolutely correct. This part which is not the part of A, except A. What is except A? 10 and 12. Because these are the elements which belongs to B but not A. So you can read it like this, B but not A. So that way you will never make a mistake. So difference of the sets. Let's understand it from one more point of view. So this green part is, dear children, this is A minus B means this is A but not B. And this blue part is B minus A means B but not A. And this pink portion is the common to both of them. So in case I have to find out this A minus B, what I should do? From A, if I remove this part, A intersection B, I'll get A minus B. And from B, if I remove this part, then it will become B minus A. So like that. And this. So these three parts are mutually disjoint sets. That means nothing is common between these three. So here four sets A, B, C and D are given, and we have to find out A minus B. A minus B means the elements which are part of A but not B. That means we will remove all the elements from A which is common with B. So 3, 6, 9, 12 I will not write down because it's common with B. Then 15, 18 and 21. But if I write B minus A, then I have to see that elements of B which are not the part of A. Reverse order. So 4, 8, again 12 is common, so remove this, 16 and 20. And one more thing, dear children, that A minus B is not equal to B minus A. What does it mean? It's not commutative. So difference is not commutative. Similarly, we can find out C minus D. C minus D will become Elements of C which are not the part of D. 2, 4, 6, 8, 10 is a part of D, so remove this. Then 12, 14 and 16. So our next concept is symmetric difference. So first let's understand with the help of this Venn diagram that what is a symmetric difference. So this portion, that common portion, if I remove, what I will get? A minus B as well as B minus A. So this all green portion is the symmetric difference. The symmetric difference, also known as the disjunctive union of the two sets, is the set of elements which are either of the sets and not of the intersection. That means they belongs to exactly one set, either A or B. So symmetric difference of set A and B is commonly noted as like this. We use these symbols and mostly we will use this symbol. Okay, so A symmetric difference B is equal to, what is this? A minus B union with B minus A. That's the way to find out A symmetric difference B. Disjoint sets, two sets are said to be disjoint sets if they have no element in common. That means disjoint, nothing is joined between them. So two disjoint sets are the sets whose intersection is an empty set. So let's see an example A and B. So A, I had taken some even numbers. On the set B, I have some odd numbers. And nothing is common between them. So A and B are the examples of disjoint sets. So whenever we have to prove that two sets are disjoint or not, check that A intersection B is equal to 5. Which of the following pairs of the sets are disjoint? First part 1, 2, 3, 4, and this side in the set builder form it is written x is a natural number, x is more than equal to 4 and less than equal to 6. So let's do the first part. Left hand side 1, 2, 3 and 4. Right hand side, let me label it as A, and on the right hand side we will make it B. So 4, 5 and 6. So anything common between them? A intersection B. Find out that. Yes, 4. So it's not an example of disjoint set. Next, again you can check that E is common. So this is also not an example of disjoint set. X is an even integer and X is an odd integer. And as you know that nothing is common between even and odd. So in this case, A intersection B will come equal to 5. So I can say that these are the disjoint sets. So that was all about today's video. So hope you enjoyed it. Happy learning. Thank you.